Okay, so for chapter 4, remember that in chapter 4 we talked about probability. We did a lot of different problems in chapter 4, so I'm going to try to just summarize really quickly so that you can get the basics back into your head. So we did a lot of problems initially with cards and with dice. So be sure that you remember that if a problem asks for a probability of something happening with 2 dice, remember that there are 36 things in the sample space. Okay, and so your sample space is listed in this box right here, but you want to remember that 2 dice, those problems are out of 36. Okay, remember your deck of cards. If you are not familiar with a deck of cards, you probably want to take a picture or print it out, something so that you have that handy when you're taking your test. Okay, remember that a deck of cards has 52 possible outcomes. So if you're working a probability problem with a deck of cards, those problems are going to be out of 52. Okay, remember that your basic formula for probability is that you're going to take the number of favorable outcomes, which are the outcomes that meet the condition that you're being asked about, over the total number possible. All right, so the total things in the sample space. All right, so I'm just going to work a couple of really easy ones with you. So something like this, you toss a coin twice. You would want to be able to list out the sample space, but you guys could do that because you did it in class with me. Okay, so 2 coins or a coin twice. You could do both heads, both tails, heads, tails, tails, heads. All right, find the probability that you pick exactly 1 tail. Okay, so this is going to be out of 4 because there are 4 things in the sample space. Exactly 1 tail would be this one and this one. So 2 out of 4, which would reduce to 1/2. Okay, so something like that. What if you toss a coin 3 times? This sample space we got from a tree diagram. If I were taking the test, I would probably write this sample space down in my notes for chapter 4 so that when I got to a problem like this, I would have it and that I wouldn't have to come up with that sample space again. All right, so out of 8, because there are 8 things in the sample space, we want exactly 1 head. So that would be this one, and this one. So 3 out of 8. All right, so that takes care of your coin tosses. Okay, so what about 2 dice? Find the probability of rolling a sum of 4, 8, or 12. So remember, for the 2 dice, we know that we're out of 36. Okay, and then you need to write down the ways that you can roll a 4, 8, or 12. So for a 4, you could roll a 1 and a 3 and a 1, a 2 and a 2. For an 8, you could roll a 2 and a 6 and a 2, a 3 and a 5 and a 3, and a 4 and a 4. And for a 12, the only way to do that on 2 dice is a 6 and a 6. So once you make your list, then you'll count the number of outcomes that you just marked off. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 36 reduces to 1 out of 4. Okay, so that would be 2 dice. A card coming out of a deck. Remember, these are out of 52. So if I wanted to do the probability of selecting a heart, there are 52 cards in the deck. There are 13 hearts. So that would reduce to 1/4. Okay, and then remember that these problems with the or and the and were a little bit tricky when we did them the first time. Or means that you're going to merge your 2 groups together, but you're not going to count on anything twice. Okay, so we're talking about hearts and queens. I'm going to go back to my cards for just a minute. All right, so here are my hearts. Here are my queens. All right, and I'm not going to count this card twice, so I've got to be careful with that. All right, and then I'm just going to count. So there are 13 going across, and then 14, 15, 16. All right, so 16 out of 52 would be what we would have there. So 4 out of 13. And then when we have the and in between, that is talking about something that meets both conditions. So the only card that is a heart and a queen is this one right here. That one is a heart and a queen. So there is 1 out of 52 for that last one. All right, so that kind of covers the basic probability problems with the cards and the dice and tossing the coin. From there, we worked on problems that had the or in between them. So remember that you had 2 formulas, all right? Your formulas were based on whether the events were mutually exclusive or not. So mutually exclusive meant that there were no outcomes in common. So if they were mutually exclusive, you use the first formula. If they were not mutually exclusive, you use the second. And again, mutually exclusive means that there is no outcome common to both groups. All right, so let me get an example here for mutually exclusive. All right, so a box contains 3 glazed donuts, 4 jelly donuts, 5 chocolate donuts. If a person selects a donut at random, find the probability that it is either glazed or chocolate. So you're keying in on the word or. You're saying to yourself that glazed and chocolate are separate in this box. You have glazed donuts and you have chocolate donuts, but you don't have any donuts that it says are both. All right, so I'm going to assume these are mutually exclusive. So I'm going to break this up and look at them separately and put a plus sign in between. So altogether in the box there are 12 donuts. So I know that both of these are out of 12. There are 3 glazed and there are 5 chocolate. So we're looking at 8 out of 12 or 2/3. Okay, so that's an example of a mutually exclusive problem. All right, let's look at this one. This one is one where it is not mutually exclusive. We've got our or in between, but we know that we can have nurses who are males. So we have this overlap between these two. All right, so I'm going to write out this formula. I'm going to do the probability of choosing a nurse plus the probability of choosing a male minus the probability of choosing a nurse and a male. So if I add up all of the numbers in the chart, I'm going to get 13. Okay, and actually that's already kind of done for you here. They're telling you that the total is 13. Okay, but you could definitely get 13 by adding up these 4 numbers. Okay, so I know that all of my probabilities are going to be out of 13. So the first one I want to look at is what is the probability that I pick a nurse? And here we're talking about anybody who is a nurse. So it doesn't have to be a male or a female, just a nurse. All right, so if I look at my chart, how many are nurses? So that would be those 7 and that 1, which makes a total of 8. All right, so I have 8 out of 13 for the nurses. Okay, what about the males? If I'm looking at the males, I'm going to be looking at anybody who's a male. So these 3, right? And that total is 3. And then the last one I want is nurses and males. So these are the people that meet both conditions. And so nurses and males, let's see how many we've got there. Nurses and males, that would just be that 1 right there. Okay, so 1 out of 13. We add and subtract 8, 9, 10, 11, minus 1 would make 10 out of 13. All right, so that gives you an example of a mutually exclusive or and a not mutually exclusive or. All right, from there we worked on the and problems. So remember on the and problems, And means to multiply. So on a problem like this, if we didn't have a data set given to us, we would do a multiplication. But this kind of problem is easier than that. And the reason that it's easier is because they've actually given me exactly what I need in order to find the answer. All right, so nurses and males, I'm going to look at that, and this is what we've got right here. So how many do we have that are nurses and males? That's just going to be that 1 out of 13. Okay, so another way that we can work on an and problem would be something like this. All right, so the problem says a poll finds that 46% of Americans say they suffer stress at least once a week. All right, so I know right now that the probability that someone is stressed (46% or 0.46). We're going to select 3 people at random, and we want to find the probability that all 3 suffer stress. So remember, all is an indicator for an and problem. We look at each person separately. So the first person says that they suffer stress, 0.46. Remember, we're doing and, which means multiply. The second person saying that they're stressed, 0.46. And the third person saying that they're stressed is 0.46. All right, so I'm going to multiply those 3 numbers together. It gives me 0.097 for my answer. All right, the second part says none say they suffer stress. So that means the first person doesn't suffer stress. So that would be 0.54. 46% say they do suffer stress. The other 54% don't. And we're selecting 3 people, so we'll do the same sort of setup here. First person doesn't, second person doesn't, and the third person doesn't. And we get 0.157 for that. All right, so again, that gives you a quick overview of your basic probability, also your OR problems, and also your AND problems.